All right, so today we are going to take notes on pink page 139 through 146. So if you want to go ahead and grab those now, that's going to be what we need for our notes and our practice for today. Some reminders on important dates. On the 18th, you'll take your Unit 5 quiz. On the 22nd, all your late work will be due, including any missing tests or missing technology projects. On the 26th, you'll take your Unit 5 test, and then on May 4th will be your final exam. All of these dates may have changed. I'm making this video at the end of January, so all of these dates may have changed if we have had a snow day or anything that has thrown off our schedule since then. So check with the sub to make sure you have the correct dates. Again, these are just the dates I have made before making these videos, but they may have changed since I made these. So again, we're looking at pink page 139 through 146. So we'll start on pink page 139, which is going to be the beginning of this unit. We're on our last and final unit of statistics, which is on hypothesis testing. So on page 139, these notes are written there for you. In statistics, a hypothesis is a claim or statement about a property of a population. So a claim has been made about a population, and we are going to run a hypothesis test. So that's a procedure for testing a claim about its validity. So we're going to take this claim and run what we call a hypothesis test to test if the claim is valid or not. So ways that we use hypothesis testing, or examples where we could see hypothesis claims, could come from genetics, or a lot of medical claims can be made. So the Genetic and IVF Institute claims that the XSORT method allows couples to increase the probability of having a baby girl. So something like that claim we can actually test using a hypothesis test. Business, a newspaper headline making the claim that most workers get their jobs through networking. Medicine, medical research claims that when people with colds are treated with whatever that medicine is, the treatment has no effect. So all of these are claims that have been made, and then what we're going to do in this unit is run samples and actually test the claim for its validity. So today we're just going to be focusing on how to write a hypothesis test. So what we want to do is, what we're going to do in this case is we are going to observe an event. So part of this inferential statistics that we're going to do is this claim has been made. We're going to run a sample, and then we're going to look at this sample and conclude if our assumptions are correct or not. So to do this, we need to know what our hypotheses are. We're going to make two hypotheses that we can test. So the first hypothesis is a null hypothesis. So this is a statement of no change, no different, or no effect. Really what that means is it's always going to be equal to. So a statement that the value of a population parameter is equal to some claimed value. So your null hypothesis will always have an equal sign. No matter which one you're writing, we are always going to write our null hypothesis with equality, because that we're saying that our null hypothesis is that there was no change, no difference, or no effect. Now, if you were to look at statistics books, there may be some that use greater than or equal to or less than or equal to. It's not very common. And in most statistics, we want to stick to your null hypothesis just being equal. So anytime we write a null hypothesis, if we're talking about a mean, we're going to use our mu symbol, just like we did in Unit 4. If we're talking about a proportion, we're going to use the P to represent whatever the proportion is. So when we're writing the null hypothesis, first thing we're going to need to do is determine, are we talking about a mean or a proportion? And then that will determine which of these two we're doing. And then we'll have to figure out what that value is as part of our claim. So really just remember, your null hypothesis is always equal. Your null hypothesis is always equal. So then from there, we're going to write our alternative hypothesis, We denote it by either H1 or HA. And this is the statement that there is somehow something different from the null hypothesis. So depending on the claim that's being made, that could be not equal to, less than, or greater than. These ones are not about equality. They're about kind of the other end. There being a difference or a change in the results. So null hypothesis is always equal. Alternative hypothesis is one of these three values here. Okay. Now, normally I would do this in class, but unfortunately I can't because I'm not there. But what I would do in class is I would flip a coin 10 times and I'd have you guess heads or tails. And I would tell you, every time you guess, I would tell you that you got it correct. So we would have 10 tallies here saying that you had the correct answer. And we're now on pink page 140. So you flipped a coin, I flipped a coin, and you said heads. I would say, you're right. You flipped a coin, I flipped a coin, you said tails. I said, you're right. And if I said you were right 10 out of 10 times, my guess is you would probably get suspicious. So from there, we could write a hypothesis. Either your null hypothesis is you actually guessed all 10 of those correctly. The alternative hypothesis is that you guessed wrong, but I said that they were right. So you weren't correct. However, I said you were. So I lied. So if we wanted to find the probability that you actually guessed all 10 of those correctly, we would have to take 0.5, right? Because your chances of getting it right are 50-50 to the 10th power. So 0.5 times 0.5 times 0.5 times 0.5, 10 times. And what you would get as the probability is 0.00097. So that means that your probability of guessing all 10 flips correctly is 0.097%. So not even 1%, not even close to 1% chance that you guessed them all correctly. So we're going to assume with the probability of that low that the null hypothesis is incorrect. I should have made that red. The null hypothesis is incorrect. And we're going to go with the fact that I more than likely lied, which I probably did. Okay, so let's actually practice writing some null and alternative hypotheses. Remember, for our case, first thing you want to do is figure out which option you're writing. Are you talking about a mean or average and you're using mu, or are you talking about a proportion or percent and you're going to use p? Then you want to make sure that you have the correct appropriate symbols. Remember, for our null hypothesis, we are only going to use our equal sign. And then for our alternative, this is really going to depend on what claim is being made. So we'll look at some examples. I think as you read the examples, you'll kind of get an idea for what that alternative hypothesis is supposed to be. All right, so if we look at our on pink page 140, if we look at these examples, it says Stanford claims their acceptance rate is 15%. So first of all, we're talking about a percentage here, right? We have 15%. So that means I'm going to use P as my letter or my part of my notation. And then remember, your null hypothesis is always that it's equal. So your P is 0.1, P equals 0.15. That's my null hypothesis, that the percentage or the proportion is 0.15. That's our claim. The alternative hypothesis is if your claim is not your null hypothesis, then we make the alternative hypothesis our claim. In this case, our null hypothesis was that it was equal, so then our alternative is going to be that it does not equal 0.15. I apologize for my terrible handwriting. But our null hypothesis, right, that it is 15%, that is our claim that we made in the null hypothesis. So then our alternative is the opposite of that. All right, so our next example says teacher 1 claims her test average is higher than teacher 2. So we're talking about an average here. So average tells us mu. And we're comparing two teacher scores to each other. So we're going to have two populations here. We've seen two population data before, two sample data before. So we're comparing teacher 1 to teacher 2. So remember, your null hypothesis would be that there would be no change. So mu1 would equal mu2. That their scores are exactly the same. Well, that's not our claim. Our claim is that teacher 1 has higher scores than teacher 2. So since we didn't write our claim in our null hypothesis, we write it in our alternative hypothesis. So mu1 is greater than mu2. And this here is my claim. Okay, so let's go ahead and look at some more examples. Miss B claims that more than 90% of students will pass the test. So we're talking about, right, I have a percentage here. So I know that I'm using a p-value. My null hypothesis is always equal. So I make p equal to 0.9 or 0.90. Now, that is not the claim that's being made at the top. I am claiming that more than 90% of students will pass the test. So since that was not in my null hypothesis, that means it's going to be in my alternative hypothesis, that p is more than 0.9. And in case you have forgotten, and it's very common that you have, this symbol is greater than, and this symbol is less than. So you may want to write that somewhere. Last semester I learned that is not commonly remembered. And then because I claimed that more than 90%, right, my alternative hypothesis is my claim. It's a good idea to start identifying which one is the claim. As we start running hypothesis tests, we need to know which one is the claim and which one is not, so that when we run the test, we know which conclusion we're drawing. All right, researchers claim Dutch Bro rates of customer service is better than Starbucks. So we're doing a rate of customer service, so a rate would be like a percent or proportion. And I'm comparing two populations to each other, right? Dutch Bros versus Starbucks. So I can make Dutch Bros P1 and Starbucks P2. Now remember, null hypothesis is always equality. So P1 equals P2, that their rate of customer service is equal. Well, that's not the claim being made, right? The claim is that Dutch Bros customer service is less than Starbucks. So because we didn't do our claim in our null hypothesis, we're going to do the claim in the alternative hypothesis here, that P1 is less than P2. Okay, so hopefully we're feeling okay about this. Unfortunately, there is one part that gets a little bit complicated, right? We've said that our null hypothesis is always equal. However, if our claim has equality in it, that's going to be kind of the exception to the rule. So, only when your claim has equality in it. So only if my claim, right, is something like less than or equal to or greater than or equal to, do we use this. If your claim is just less than, just greater than, or just equal, we do what we did in those first four examples. So this is just a one small entity exception. If your claim has equality in it, you are still going to write it as equal. This part will not change. This is still going to be equal, though you're kind of getting rid of part of the equation, right? We're only talking about equality here. So we're rewriting this to just represent equal. So then the opposite of that, right? If it was less than or equal to, then the opposite of that is greater than 195. So this really is our claim because it has a quality in it. Anytime your claim has a quality in it, then it's your null hypothesis. And we'll look at some examples that hopefully will make sense, but this is the exception. The ones we just did before this, those 4 examples that we did, those are the ones you're going to see most common. These are kind of the exceptions to the rule when we have a quality in our claim. So let's look at 2 more examples. So Miss B claims at least 90% of her students. So this is a big thing. If it says at least, that means I'm claiming that 90% or more, so 90% or more are going to pass the test. Not more than, at least means 90% or higher. So my claim has a quality in it, right? It's greater than or equal to. We're only going to write it as equal to, but this is my claim. We're only going to write it as equal to because null hypothesis, we only use equal. And then my alternative is the opposite of that. So if greater than or equal to is my claim, then it's less than. That's my alternative hypothesis. Remember, this is the exception when our claim has a quality in it. All right, let's look at another example. So College Board claims the average ACT score is at most a 27. So at most is another form of equality. At most means 27 or lower. 27 is the highest value. So this score, and it's an average, so I should be using mu. Mu is going to be less than or equal to 27. Again, my claim has a quality in it. So that means when I write this as equals 27, this is my claim. And then the opposite of that, right, if it's less than or equal to, would be that it's greater than 27. Okay. So now I want to do a little bit of practice. Of writing these null and alternative hypothesis, because I think that will make it easier. And we're going to write literally every problem we do in this unit. We're going to write null and alternative hypotheses. So if you're struggling with it, I promise over time, this is going to feel a lot easier by the time we're done with this unit. So with that being said, go ahead and grab page 143 and 145 in your workbook. Page 143 and 145 in your workbook. And we're going to look at some examples together, and then I'll have you do some on your own. So 143 and 145. Okay, so here's what we're going to do on 143 and 145. So we're going to, in all of these, here are the claims, and we're going to match them to the appropriate null and alternative hypothesis. So first we're going to figure out, are we working with a p value or a mu value? And then which one of these null and alternatives are correct for our claim? So I'm going to do a couple on here, and then I'll pause, let you try the rest. You can check your answers, etc. But let's look at a couple together. So it says, last year the government made the claim that the average income of the American people was $33,950. So the fact that we're talking about an average means we're looking at our mu value. So we're looking at, on this page, we're looking at mu values. Now, they're just claiming that it is equal to 33,950. So again, our null hypothesis would be that it equals 33,950. And that's our claim. So then the alternative, right, if our claim is that they're equal, then the alternative is that they're not equal. So that mu does not equal 33,950. So if I go to this page, right here, right, I have a mu equals and a mu doesn't equal. So this can be number 1. And I'll make this 33,950. And I'm using the same number for both of these. And then I'm going to mark this with the C because that's my claim. And again, we should really be practicing identifying our claim every time because it's going to come into, it's going to be very important when we're actually running our hypothesis test. Okay. Do these results provide convincing evidence that Shaq has significantly improved his free throw shooting by 53.3%. So we're looking at a percent. Yes, so we have a p-value. So my null, remember, is always equal. So my null hypothesis would be that his percentage equals 53.3. Or actually, sorry, I should turn that into a decimal. 0.533. Right, when we're talking about proportions, sorry, I'm way off on this one. We're talking about a percent or a proportion, so we should be using a p-value. I think I said that, and then I wrote mu. I don't know why. But we're talking about a percent, so we use a p-value. And then we always like to write our percents and our proportions as decimals. Again, that's going to come into play when we're running our hypothesis test. We have to run them as decimals, not as percents. So then they're asking that it significantly improved from 53.3%. So we want to know, we're testing the claim, is it greater than 0.533? And this here is our claim. So then we're going to see which one matches that. If I go back to page 145, I need a P and a P greater than. So I'm going to use this one here for number 2. And I'll put 0.533, 0.533. And then this again is my claim because I want to see, has it improved his shooting? If you put it here, these two are exactly the same. So it doesn't matter which spot you put it in. They're the exact same setup. Okay. So let's do a couple more together. So number 3, test the claim that the mean amount owed by all customers is greater than $150. So the mean amount, we're talking about a mean. So that means, so for both of these, I should be using mu and mu. Remember, our null hypothesis is always that it's equal. But that's not our claim. Our claim is that it's greater than 150. So since we didn't write our claim here, that means we're going to write our claim here as greater than 150. So then let's see if we have something to match on here. I need a mu equals and a mu greater than. So there's one right here. Make this number 3. Right, this is 150 and 150. And then this was our claim. Okay, if you feel comfortable, I would pause this video, keep going, try to fill out as many of these as you can on your own. I'm going to go over a couple more together just in case people are not feeling comfortable with this process, and then let you finish up the page on your own. But if you feel like you understand, I would pause this video, try it on your own, and get that practice in. But I'm going to look at number 4. So a Caribbean island advertises its average summer temperature is 75 degrees. So we're talking about an average, so that means in our null and our alternative hypothesis, we should be using mu. And then the claim is that it is 75 degrees. So this here is our claim, that it equals. So then if our claim is our null hypothesis, then we just make the opposite our alternative hypothesis. So if equals, the opposite of equals is does not equal 75. So we'll go over here, see if there's one of these that we can use. And there is right here. You can make this number 4, 75, 75. And this is in fact my claim. That's wrong. I wanted a not equals. I'm sorry. This is way off. Oopsies. I was looking at the wrong thing. This is my equals and does not equals. Should be number 4. I'm so sorry. I was looking at this one and filling out this one. Silly me. Okay. Right, we were just matching the format we have here to the format here. And this one is our claim. Okay. Number 5, 2 machines fill 32-ounce cartons with cereal. The quality control manager claims that cartons filled by machine 1 have more cereal than those filled by machine 2. So we're comparing 2 populations to each other, and we're looking at the average that's being filled, the amount that's being filled from each of these. So I'm comparing a mu1 to a mu2. So your null hypothesis would be that they're equal, right? That there's no difference between the two of them. Mu1 and mu2 give you the exact same amount. So then our alternative hypothesis, right, that's not our claim here. We're not claiming equality. We're claiming machine 1 has more cereal than machine 2. So this would be mu1 is greater than mu2. And this here is our claim. So I would go find one that matches on page 145. Mu1 is greater than mu2. And then we'll mark this as our claim, right? There's no numbers in this case to write. We're just comparing mu1 and mu2 to each other. All right. All right, let's look at a couple more. So one of the professors concludes that a coin was minted asymmetrically and it lands on heads more often than it lands on tails. So this one's really a proportion. It doesn't have a number in it. However, we know what the true percentage, we know what the percentage of flipping a coin and landing on heads should be, right? The proportion should be 0.5, right? If I flip a coin, half the time it lands on heads, half the time it lands on tails. Sorry, I got interrupted. Going back to number 6. So we know that the normal probability of you flipping a coin and it landing on heads is 50%. So our null hypothesis is that we would get that normal 50%. But the claim here is that it would land on heads more often than it lands on tails. So that would mean, right, that my alternative would be that it's actually greater than 0.5. So if we go up here to number 6, I can use this format of 0.5. And the reason that the reason we didn't use a P1 and P2 is that this is not 2 populations, right? A coin has a heads and a tails. So it's really one population that we're comparing. If it was talking about, I don't know, flipping a coin and rolling a dice, then yes, those would be 2 separate populations. But flipping one coin is not 2 different populations, which is why we're using just a regular P value versus the percentage of getting heads versus not getting heads. Okay, let's look at number 7, and then I'm going to do number 10 and let you finish the page. So number 7 says, is there a difference in average salaries for men and women? So here we have 2 different populations. We're talking about an average. So we have mu1 and mu2. And the question is just, is there a difference in average salaries? So our null hypothesis would be that there is not, that they are equal. But then our alternative, right, is we want to know, is there a difference? So are they not equal would be our alternative hypothesis and our claim. So if we go to find one that matches that would be down here. So this would be number 7. And then we're going to use this as our claim. All right. So then for the next one, I want to look at number 10 because that's that exception to the rule that we talked about. Those were those annoying exceptions. So it's claimed that it has been claimed that at CSU at least 35% of students live on campus. So this claim at least means 35% or more. So greater than or equal to 0.35. So remember, this has equality in it. So that means that this is part of our claim of our equals 0.35. So then we take the opposite of that to find our alternative hypothesis, right? Since the initial one is our claim, we're going to take the opposite of this p-value. So instead of greater than or equal to, it will be less than 0.35. So that one will go ahead and be one of these two. I'm just going to write it here. Yeah, so that's our exception. Because our claim had equality in it, we still just write it as equals. Don't understand why, but that's how statistics wants us to do it. And then we'll switch the sign for our alternative hypothesis. All right, so I want you to finish the last couple. I left you like 5 or 6 to do on your own. Finish those. Check your answers. With the sub, they should be posted at the front, or the sub has a copy of the answers. And then once you're done with that, you can watch the next video, which is going to complete our notes.